Okay, the next part is binomial approximation. I'm calling it binomial approximation. Sometimes it's called normal approximation, but whichever it is, if you see the word approximation, you're going to do this. But before we do whatever the process I'm going to show you, we need to understand what is binomial doing in a normal distribution. At the beginning, we said normal distribution is done for continuous data. Then we know binomial distribution is done for a discrete data. So the essence of it is we can't mix a binomial into a normal, because discrete data, continuous data, there is a complete distinguished difference, because this takes specific answers, this takes a range of answers. But rule says, or like the theory behind it says, if I have too much of a data, discrete data, too much discrete data, and the probability is so close to 0.5, then using a binomial distribution to calculate the probability is not nice. Let's just call it like that. I'm just trying to make it simpler by saying these things, not to overcomplicate, yeah? But there is other terminologies for it. But all you need to understand is if you have too many data, let's say I'm tossing the coin 10 times, the probability of getting ahead is half. So we know this is a binomial distribution. We can distribute the data binomially. Probability of exactly getting 3 heads, we would use the binomial PD, and then we would have put x as 3, n as 10, p as half, and we would have calculated it if x is equal to 3. If x was greater than 3, we would have done 1 minus probability of getting less than or equal to 3. We would have put x as, in this one, we would have done binomial CD because it's cumulative. The options are cumulative, like less than. We would have put x as 3, n as 10, p as half. Once you get the answer, we would have subtracted it from 1. We would have got the answer for more than 3. This is binomial distribution for us. But I'm not revising that. What I'm trying to say is, if it was 10 times the coin was tossed, it's okay. If the coin was tossed 50 times, it's okay. If the coin was tossed for 100 times, or let's say 200 times, then it has gone a bit too much. And the probability is close to 0.5. It's exactly 0.5, but let's say close to 0.5. In this case, rather than performing a binomial distribution and calculating the answer, we can bring this distribution to a normal distribution. So in a normal distribution, we don't have n number of trials. We are not trying certain amount of time. We are not trying with the probability. Instead, we are doing average, and we are doing the standard deviation. So we are trying to when we do normal distribution, this is the notations that we use. Unlike in binomial distribution, it's n and p. So the rule says if it's too much data, we have, and if the probability is close to 0.5, we can use an approximation technique to convert the data from a binomial to a normal distribution, convert binomial to normal, and do the question as normal distribution. That's as simple as that. In the question, he would specifically say using binomial approximation, or using normal approximation, or using a suitable approximation. There's only one approximation technique that you're going to learn in your A-levels. So that's the normal approximation is the only approximation, and you're just going to convert the data from binomial to normal. In order to do that, so in this example where I've said n is 200, p is half, this is my binomial distribution. I'm going to convert this data to a normal distribution data. If I'm converting from a normal to a normal, binomial to a normal, I need to know what my mu for this data. For this specific data that I have, I need to know what's the average is, and I need to know what the standard deviation is. And there's a formula for this mu and sigma. And do not panic, it's given. And I'm thinking that it's the formula sheet. So in the formula sheet, if you go into this discrete distributions, it says here mean NP. It says variance NP times 1 minus P. So it says these two things. That's exactly what I'm going to use. Your mu is NP. Sigma is NP times 1 minus P, and then square root this because it's standard deviation. So N is 200 and P is half, and then this is 200 times half, and then 1 minus half, and then square root it. So if you find the calculation here, that's 100, and then 100 times half, which is 50, so that's your standard deviation. So 100 and then square root of 50.